So,
Can you annotate in the screen the way I showed you?
can I say something?
Yeah, sure.
The question I thought from the left hand end meant that it will be somewhere here in this direction, so I got confused.
Okay, okay. So
I thought
actually,
it will be
I
further away from the pivot, and then I did my calculations and saw that it doesn't
so
match.
should I explain again?
No,
Hmm?
no, I got no answer.
Should I show you the diagram how to draw, how to
No,
explain? Hmm?
no, no.
So you will show me by annotating. Like you can use the conditions for equilibrium here, right?
Yes, here it's 6 Newton over here, so that means
Mm-hmm.
on that means here and the other force working here, the sum will be 6 Newtons.
Mm-hmm.
So if it is 2, then this one over here, this is 4 Newton. So it's
Mm-hmm.
either A or it's B, either of
Mm-hmm.
these two. Oh, I have to
Mm-hmm.
so it's either of the two. And when we calculate it at B, it says 4 Newton at 15 centimeter from the left hand end. So it will be somewhere here.
Yes, yes.
And the moment over here is
Where is your pivot here?
pivot. The pivot is over here. This one.
Yes, yes. Yeah, that is the point. We should identify first the pivot, then we can get the
Yeah.
clockwise and anti-clockwise movement, right? In the first condition we got that is 4 Newton, but for getting the second condition, clockwise and anti-clockwise movement, we need the position of pivot, right? So the answer is
Got from
Bangladesh.
yeah.
The answer is Bangladesh. So your movement for anti-clockwise movement, it is from here, right? So it is
Yes.
10 multiplied by 2, 20 Newton centimeter. Then your clockwise movement should be also 20. That is from pivot it is 5. Then from left hand it is 15. Okay, that's it.
Instead of subtracting, I added the
Mhm.
values and then I got a bigger number. And I got
Mhm.
confused where I went wrong.
So now you are clear, right?
Yes.
You have
I
to.
got confused at A and B.
Mhm. We have to first identify the position of the pivot
Yes.
for second condition, clockwise and anti-clockwise movement. Okay, and this one is we are done.
Proceed.
Mhm. These are also easy. Mm. This one you have got confused, right?
Made mistake in this
12.
one.
Mm. So what's your answer here? What's the answer of it? 12,
B for Bangladesh.
Bangladesh.
Yes.
Yes, because from pivot
It
there is
is
the
for distance.
yeah. What is biggest from the pivot? The distance most. Okay, then we have this one is also easy. Okay, then nothing is more here. So should we start new topic now?
Yes.
Okay, deformation will start now. Topic 6. So here we go. We have this topic 6, deformation. Huh? So can you read the learning outcomes from deformation? Yeah.
Candidate should be able to, number A, state that a force may produce a change in size or shape of the body. B. Plot, draw, and interpret extension load graphs for an elastic solid and describe the associated experimental procedure. C. Recognize the significance of the term limit of proportionality for an elastic solid. An understanding of the elastic limit is not required. D. Calculate extensions for an elastic solid using proportionality.
Okay, so we have here the first thing, change in size and change in shape. The one we told you when we discussed in dynamics, that time we had the effect of forces on object, right?
Yeah.
How can force change the motion of the objects? We had those three related to motion. Now we have the effect of force uh, change the size and shape of the body. So to change the size means volume, right? If it is volume change, then we can say this is size change. If the volume same, but only there is any change in, you know, overall features, then we say shape change, right? Is it
Yeah.
clear? If the volume is same, but for any structure is changed, that time we are saying shape change. Is it clear? But if we say size change, that means volume is changed. We are going to discuss here details. What is change in volume? What is change in shape? Then we have the deformation. Like we have to apply force to get the spring of the, you know, any spring. Like it's mainly the metal spring we are using. They are saying elastic object, elastic solid. So that one we can get the extension according to the load. And if you give load, it will extend according to relationship. Within a limit, it will follow that relationship. But if you cross that limit, then it's not following that proportionality. That's called elastic limit. Like one spring, if you give 100 gram, then you are getting the extension 5 millimeter. For 200 gram, you are getting the extension 10 millimeter. This way you can go 900 grams. But if you are crossing 900 grams, you will see for 1000 grams, it will extend little bit more. Okay, so this is called crossing the limit of proportionality. For example, after giving 1000, the extension is now 7 millimeter. till 900 millimeter, it was 5 millimeter, but now for that value, it's crossing that limit. So this is called limit of proportionality. Okay, and Hooke, one scientist, he introduced this rule, or he observed by this experiment. That's why, according to his name, this law is named as Hooke's law. Okay, let us go for detail here. Change in change of shape, and we have here change of size. We have here discussions. Then we have Hooke's law, limit of proportionality. That's it. It's very small topic. Very small topic. Yeah. You see, only one content is there, 6.1 elastic deformation. So let's start. Here, can you read from here? Change of shape.
Change of shape. When a force acts on an object, the object may change shape by bending, switching, or compressing, or a combination of all three shape changes. However, to change the shape of a stationary object, there must be more than one force acting. We do the following. When an object's ends pass each other, for example, when an Olympic diver stands on the end of the diving board, a beam is bent. Two equal forces act inwards, support left hand end. The third force bends the right hand end downwards.
Okay, so you write this topic name. First, you write this topic name. Did you write topic 6
Yeah.
deformation? Then you write change of shape. Change of shape in bracket after writing this change of shape. You in bracket you write here. In bracket you write volume remains same. Huh?
Okay.
Then you write example. Hmm. Example. You write. I'm writing the examples. Making different structures by a porter using clay. Then bending an iron rod. Then stretching a rubber band, etc. So this part is done. Change of shape. We are done with this part. Are you done with writing?
I'm writing. I'm in the last line.
Yeah, yeah, right, right, no problem. Right.
I finished writing.
Then we have here change of size. Yeah, read this please.
When we inflate a balloon, there is a change in size. Volume increases.
Hmm. Then you continue.
When we squeeze a sponge, there's a change in size. Volume decreases.
Yes, so you write here change of size in bracket. You write volume changes, huh?
Okay, sir?
Yeah. Then you write these two example. Example: inflating a balloon and then squeezing a sponge. These two example, right?
Finish writing.
Yeah. Squeezing a sponge. Huh?
Yes, sir. Finish writing.
Okay. Now Hooke's law.
Extension and compression. Extension happens when an object increases in length. The compression happens when it decreases in length. The extension of an elastic object when force is applied, such as spring, is described by Hooke's law. The extension of the object's length will be proportional to the load causing that extension, provided the elastic limit is not exceeded. For example, if the force is doubled, the extension is doubled.
Then we have the numerical expression of this law. That is, F is directly proportional to X, where X is the extension and F equals Kx. So K is here spring constant. We wrote here what is F is force, K is spring constant is written here, and X is extension. So there is came all the things. Hmm.
Okay, sir.
Then you write the heading Hooke's law. Huh? After writing this heading Hooke's law, then you write this one only. The extension of the object length will be proportional to the load, causing that extension provided the elastic limit is not exceeded. So done.
Yes, almost. Let's finish.
Then you write the numerical expression.
Written
Yes,
it
all
already.
three lines. All three lines you write.
Yes, I copied all.
Mm. Done. Mm.
I finished writing.
So if you are done with this, then you solve this example.
Okay, so
Yeah, read this example, please.
a force of 3 newtons is applied to a spring. The spring stretches reversibly by 0.15 meter. The fact that the spring stretches reversibly means that it will go back to its normal shape after the force has been removed. Calculate the spring constant. Hint: first rearrange to find K, then calculate using the values in the question.
Mm-hmm.
So I'm
Do it.
calculating this.
Yeah, yeah, do it. So have you got the answer?
I'm thinking. Okay, I think it's 20. Uh, uh,
Yes. What is the answer?
then I think it's 20.
Mm-hmm. Sorry?
20.
20.
20. Yeah.
Yeah, yeah. 20 Newton. Yes. 20 Newton per meter, right? The unit. The unit you'll also write, huh? Newton per meter. Okay, now read limit of proportionality.
Limit of proportionality. Spring constant is a measure of the stiffness and strength of the spring. The limit of proportionality refers to the point beyond which Hooke's law is no longer true when stretching a material. The elastic limit of a material is the furthest amount it can be stretched or deformed without being able to return to its previous shape. Once a material has gone past its elastic limit, the deformation is said to be inelastic. The higher the spring constant, the stiffer the spring. The spring constant is not the same value for different elastic objects. For a given spring, other elastic objects, the extension is directly proportional to both parts. For example, if the force is doubled, the extension doubles. This works until the limit of proportionality is exceeded. When an elastic object is stretched beyond its limit of proportionality, elastic limit, the object does not return to its original length and force is removed. In this instance, the relationship between force and extension changes from being linear or directly proportional to being non-linear. Okay.
Okay, so here you go. Here is the extension load graph. You see, we have here values, right? Though we did not mark with all the values. For example, here we have 100 gram. If it is 100 gram, then it is 1 Newton, right? Hmm.
Yeah.
Okay. This way you can mark. Huh? This way we have here 0. It starts from 0. Origin is 0. And the extension is here also 0. The load is 0. Extension is 0. That means if we apply force 1 Newton, then we have here 10 centimeter. Okay.
Okay.
10 centimeter, right here 10 centimeter, label this way. Then we have 20 centimeter, 20. Then we have 30 here, 30. This way go on. 30, then 40. We have here 40. Then 30. Okay, then here we have 0, 0, 10, 20, 30, 40. And right, and the x-axis we have 2, 3, 4. 2, 3. Here we have 1, 2, 3, 4. Okay, 1, 2, 3, 4. So they gave here 4, you give here 5, yeah? So that it is matching here. You give here 5. 3, then 4. 1. So is it clear?
I have taken the notes.
Yeah, yeah. So this part you do not need, like the shaded one you do not need, and this part also you do not need. This is a discussion of A levels. We don't discuss it here. Energy, about the energy calculations, we do it in A levels.
Yes, sir. Sir, I have drawn the diagram.
Yeah, labeling and drawing is done, right? And figure
Yes, sir.
caption, figure caption also you give, right?
Yes.
Okay, so you write here about this. This part you write, huh?
Okay, sir. Sir, I have taken notes on this.
Okay, very good. Now we have this one. Done. Okay, done.
Yes, sir.
Yes. So, what is Hooke's law, Adrita?
Bookstore. Bookstore
Hmm.
says that when we add a load to a spring, its extension will be proportional to load. The
Okay.
length will be
Hmm.
proportional before we reach the elastic limit. After we reach the elastic limit, this law will not be.
What is the difference between the change in size and change in shape?
Um, when the shape changes, it's just the shape, the volume remains the same. But when you change the size, the volume changes as well.
Okay, example, change in
Example,
size.
when we blow a balloon, it expands, and volume increases.
So, question number one, MCQ. Right.
A metal wire is suspended from a cord and when its objective mass attached to the roller. The table shows how the extension of the wire depends on the mass of the roller, between which values of mass does the limit of proportionality lie.
Yes. So, what is your answer? Check.
I think it's between 4 kilograms and 6 kilograms.
Mm-hmm. So, your extension between 0 and 2 kg, right? What is the extension?
0.35 millimeters.
0.35. Then for 4 kg,
4 kilograms is 0.35.
0.70. Then for 6, it is 1.05. So it's increasing by 0.35
Yeah.
for every 2 kgs. For 8, how much it is?
4.55.
0.45. 0.45, right?
In each one.
Yeah, so it's it's more than the previous, right?
Yes.
So here is somewhere we are having the limit of proportionality or elastic limit, right? Isn't it? It is the place where we are not getting the proportionality. That means in this place there is somewhere we are crossing the limit of proportionality, right? Isn't it?
Yes, sir.
Yeah, so our answer is C. Answer is C here. 6 kg, in between 6 kg and 8 kg, somewhere we have the limit of proportionality. Okay.
Okay, sir.
Uh, maybe you need more explanation. Like if you think this way that we are having here 2 kg, but we can also make it for 1 kg, right? Isn't it? If it is 1 kg, then it will be 17 point like 0.175.
0.175.
Yeah, 0.175. The extension is 0.175. So maybe it's working. This limit of proportionality is working till 7 kg, isn't it? This way we can make the
Dimension.
segments smaller and smaller. We can also make it for 0.5 kg, right?
Yes,
So
sir.
this way, somewhere in between 6 and 8 kg, somewhere the limit of proportionality is there. That means still there, maybe it is 7 kg or 7.5 kg, or it can be 6.5 kg. There it's following Hooke's law. After that, it's not following. That's why we can say the limit of proportionality in this range, 6 and 8 kg. Is it
Okay,
clear?
sir. Yes.
Okay, now
Okay, the graph shows how
no,
the
question
extension
number
of
two
spring.
is your homework. Question
Okay,
number two is your homework. Okay.
no
Then
problem.
question number three.
So scientists try to use a spring to make a spring balance at linear scale. The graph shows how the extension of the spring changes with the load on it. What is the total range of a balance at linear scale using the spring?
Yeah. So where we are getting the linear scale, they are asking you that one. Linear means we are having the limit of proportionality, right? Straight line. So till where we are getting the Hooke's law?
It's, I think it's 0 to 12 Newton.
0 to
No,
10,
wait, 0
right?
to 10, 10, yeah.
Yeah, 0 to 10 Newton. Correct. 0 to 10 Newton. Okay, then 4 is also your homework, okay?
Okay, sir.
4, 2 homework, then 5 is your homework,
Okay,
then
sir.
6.
An extension load graph
Mm-hmm.
started to show result of increasing load on spring, which point marks the limit of proportionality for the spring. This one, I think it's B,
Yeah,
because in
limit of
C it starts to,
proportionality.
get curved.
Where is limit of proportionality? Where it is?
I think it's at C, C or D.
It's
I'm
in,
not sure.
you are saying Bangladesh or Canada?
Canada. Hello?
Yeah, before Canada there is also some curve line, right? Little bit curve.
It looks a bit straight.
A little bit curve
Let
we
me
have.
zoom this
So
thing.
yeah, so we can say B, Bangladesh is the limit of proportionality because after Bangladesh we have little bit curve. There we are getting C. Not straight. If it is straight, it will go here. Not in C.
Oh yes, it's correct.
You can use
Yeah,
your
it's
ruler
more
also on the
visible when
screen.
it's
Yeah,
zoomed. Yeah, it seems
B
a
should
lot
be the
curved actually.
B should be your
Oh, it's
limit of proportion.
B.
So 2, 4, 5, 7. 2, 4, 5, 7. Then 8, 9. 8, 9, 10. Your homework. Okay.
Okay, sir.
Uh, 11 also. 12. Say about 12.
The graph shows extension load curves for four fibers. Which fiber is hardest to switch over the range of loads shown? Okay.
Which one is hardest?
Sir, 1 minute.
Mm-hmm.
I have a question.
Mm-hmm.
Hello.
Yes, yes.
The harder the spring is, the less it will stretch, right?
Yeah. If it is
So
harder,
it's
then you will have less extension, right?
yes, it's D.
Yes, it's indeed Dhaka. So clear, right?
Yes, sir.
So what is your homework?
Homework
11.
number 2, 4, 5, 7, 8, 9, 10, 11.
So can you write in your emo this homework? You write
Topics or
homework.
the answers?
No, 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 not the answer. Only the question number you write.
Okay, sir.
In emo you write. You write homework on topic 6, worksheet, MCQs. Then you write the number. That's it.
Okay, sir.
Have you written?
Yes, sir.
Yeah, yeah, I got it. Homework on topic.
I wrote number. It got changed to no one. I don't know. I thought it was right.
Okay, wait. Let me see. Homework on topic 6, worksheet. MCQs number 2, 4, 6, 2, 4, 5, 7, 8, 9, 10, and 11. Okay, okay, well done. So that's all for now, huh? Okay.
Sir, when I speak because my mom wanted to talk.
Sorry,
My mom actually wanted to talk.
do you wants to talk to me? Hello,
Hello.
hello.
Hello, sir. Hello.
Yes, yes. Tell me, please.